Okay, so today we'll be treating the method of circuit analysis, and by the end of this video, you'll know which method to use and why without guessing. Method of analysis feels overwhelming because there are too many options. You have the KCL, the KVL, nodal analysis, and so on. And students keep asking which one is correct. The truth is every one of them works, but it just depends on the circuit, which one works easiest. Here we have the different method, and I group them under laws, systematic method, and its simplification. The laws is basically we have KCL and KVL, and KCL is talking about the sum at a point is equals to 0, meaning the sum of the current at a point is equals to 0, meaning the sum of the currents entering the point is equals to the sum of the currents leaving that point or the node. Also, KVL is talking about the sum of the voltage in a loop is equals to 0. We'll be dealing with that. We also have the systematic method, which is the nodal analysis and the mesh analysis. The nodal analysis is built on KCL, meaning at each node, the sum of currents leaving is equal to the sum of currents entering that node. Then we also have mesh analysis, which is talking about the sum of voltage in that mesh is equals to 0. Thevenin and Norton then superposition, they just simplify the circuit. They are used to make complex circuits simpler, not to replace nodal or mesh analysis. Now, when to use nodal analysis, like when are you going to use this nodal analysis? When the node is few, like there are few nodes compared to the meshes, that means fewer nodes. When there are more current source, like there are current sources in the circuit, and it's based on KCL, so when there are like more current sources in the circuit and there are fewer nodes. Then for KVL, when there are fewer meshes and there are more voltage sources. Why? Because it uses KVL to solve it. Also, another way of doing either to use nodal analysis or mesh analysis is the fact we need fewer, the one that gives fewer equations. Because when solving it, sometimes in a particular circuit, we probably have 4 meshes and just 2 nodes. In that case, if you should use mesh analysis, 4 meshes simplify would result to 4 equations, but 2 nodes, if you should use nodal analysis, will just give you 2 equations. So in that sense, it's better you use nodal analysis. Let's move to this example. So at first, let's identify our nodes. This is a node here, V1, and this is a node here, V2. In this, we have 2 nodes here, and if we should check the mesh, we have 3 mesh. We have 1, 2, 3. So in this case, it's better to use nodal analysis. Secondly, we have current sources. This is 1 current source, this is 2 current sources. And as I said earlier, when you have current sources, it's better to use nodal analysis because the nodal analysis use KCL. So the next thing you do after identifying your node, you have this is 1, the first node, the second node, and you have the ground node here. And the ground node is known as the reference node. And reference node is always equals to 0 voltage. So meaning if you're asked in an objective question, how many nodes does this circuit have? It has 3 nodes. 1, 2, 3. 1 reference node and 2 non-reference nodes. So the next thing is to give your resistor the current, the direction of the current. You can either choose any direction, either the current goes downward or it goes upward. But most times I love using my current flowing downward into the ground, and you can choose any direction in this aspect. Okay, let's choose like this. So now at V1, we have this current 10 ampere. Let's name it I1, then this I2. We give this small letter I1, I2, I3. So and I said we're using KCL for nodal analysis. So our KCL is saying the sum of currents entering is equal to the sum of currents leaving. So now we have capital letter I1 entering this node. That's I1. This one I1 is leaving, this is leaving, and this is leaving, meaning I1 plus I2 plus I2. Now what is I1? I1 is 10 ampere. It is entering v1, so that's 10 is equals to I1. How do you calculate your I1? We know from V is equals to IR, meaning I is equals to V over R. And in this case, we use V higher minus V lower over R. We assume current flow from the higher voltage to the lower voltage. So meaning the direction is flowing from here to here. So meaning V1 minus 0 over 6 plus I2 is flowing from V1 to V2. V1 minus V2 over 4 plus I2 5 ampere. So we have it as 10. So you can just multiply through by the LCM, that's 12. 10 times 12, that's 120. 120 is equals to 4. 6 times 6 here, 1, 6 here, 2. We're multiplying through by 12. So that's 2V1 plus 3V1 minus 3V2 plus 12 times 5, 60. So we say 60 is equals to 5V1 minus 3V2. That's equation 1. So now at V2, I2 is entering V2, this I2 is entering V2, and I3 is leaving, meaning I2 plus I2 is equals to I3, then 5 plus V1 minus V2 over 4 is equals to V2 minus 0 over 2. So the reason why I love the direction of my current to flow from into the ground is because if it should flow upward, it would say 0 minus V1, and that's going to give me negative V1, and I don't want to deal with lots of negative to any mistake. So we multiply by 4. 4 times 5 is 20. 4 cancel here, that's V1 minus V2 is equals to 2V2. So we have this as 20 is equals to minus V1 plus 3V2. So V1 minus 3V2 is equals to minus 20. That's equation 2. So we solve the simultaneous equation, then we get our V1 and V2. So as equation we get V1 is equals to 20 and 20 volts, and V2 is equals to 13.3 volts. So you're done with this. In some circuits, you probably see a voltage source. You see a voltage source. So in this case, we have 3 mesh, 1, 2, 3. Then we also have 3 nodes. So what are you going to do in that aspect? How can you determine it? Earlier I said when you have more current sources, you go for nodal analysis. We also have cases whereby once the voltage is between the non-reference and the reference node, meaning once you have a voltage source between V1, the non-reference node, and the reference node, automatically V1 is equals to 10 volts. So in this case, you'll be able to solve for V1. You only need to solve for V2 and V3. So going for nodal analysis here is going to be a very wise decision. Now what next? You have a 5 volts between V2 and V3, which is 2 non-reference nodes. In while solving method of circuit analysis, once you have a voltage source between 2 non-reference nodes, V2 and V3 is called supernode. So you are going to treat it as one node. Okay, let's do. So you choose the direction of your current for each resistor. Oh my bad, I omitted the resistor here. Okay, so you can choose direction here. I told you it's best to choose a direction to go downward. This is going into this. So now we give this I1, I2, I3. Then you can give here I4. Okay, so this is what I said earlier. We're going to treat this as one node. So at supernode, I2 is leaving, I3 is leaving, I1 is entering, and I4 is entering, meaning I4 plus I1 is equals to I2 plus I3. So I4 is coming from V1 and entering through the supernode, but at V3. So you say V1 minus V3 over 4 plus I1 is going to be V1 minus V2. V1 minus V2 over 2, which is because I2 is coming from V2 and entering the reference node. That's V2 minus 0 over 8 plus I3 is going to be V3 over 6. So you can multiply it by 24. We have 6V1 minus 6V3 plus 12V1 minus 12V2 is equals to 3V2 plus 2V3. So V1 is 10 volts. So 6 times 10 is 60. V3, then we have plus 120. So we have V2 here, minus 12V2, but so it needs to be minus 15V2. Then you're left with V3. So that's going to be minus 8V3 is equals to 0. So 120 plus 60 is 180. 180 is equals to 15V2 plus 8V3. That's equation 1. So also, when you have a supernode, for you to solve a supernode, you need to apply KCL and KVL at the node. So we've applied KCL, which is this. So how do you apply your KVL? You treat the supernode as a voltage. Okay, you treat the supernode as a voltage source, meaning you're saying you're having something like this. Your plus and minus 5 volts, you bring here. So you give, this is a V2. Automatically give it a plus and minus V3. So you choose like a case, you choose KCL, you go in this direction, meaning you are saying minus V2 plus 5 plus V3, the current side, the current is going through, is equals to 0. So from here we have V3 minus V2 is equals to minus 5. You can say V2 minus V3 is equals to 5. You have your equation 2, and through simultaneous equation, you get the value of V2